So, hello everyone. My name is Nora Hintsa, and I am the social media officer of the Habit Special Interest Group from the European Health Psychology Society. And on behalf of our whole committee, I would like to wish you a warm welcome to this year's final Habit SIG session, where we have our guest speaker, Dr. Eike Buabang. Just before we begin, I'd like to make a few quick announcements before handing it over to Eike. So first, if you are not yet a member of the Habit SIG but would like to become a member and subscribe to our newsletter, please email our co-lead Benjamin Gardner at benjamingardner@surrey.ac.uk. Also, you can find us and follow us on social media. There is the link for all of our platforms, including LinkedIn, X/Twitter, YouTube, and most recently Blue Sky. So please do follow us there and engage with us. And finally, we have a new WhatsApp group. We'd like to increase the engagement within the Habit SIG and create a space where people can talk anything related to habit research. For example, advertise great new papers you found, ask questions or recommendations on papers, or for example, reviewers, or suggest talks or activities for our Habit SIG. So I will be posting all of these in the chat later on, so don't worry, you can find them there as well. Finally, if you have published any habit-focused research in 2024, we invite you to send your citation to my email address, which you can find there. I will also add this in the chat. So we would like to comprise a list of all the relevant research in one place. So if you have worked on anything, we'd love to include your work in the list. All right, so then to the exciting part. Let me introduce today's guest speaker, Dr. Eike Buabang. He is a postdoctoral research fellow in the Gillan Lab, and as it happens, also a committee member at the Habit SIG. His primary research interest is the cognitive neuroscience of habits. And using experimental paradigms and EEG, he investigates how habits develop in the brain and explores implications of this for everyday and clinical applications. He is particularly interested in understanding why people engage in behaviors that are against their explicit beliefs and goals. So great topic with a lot of practical implications, can at least attest to that. Eike is an awardee of the Government of Ireland Postdoctoral Fellowship from the Irish Research Council for his project entitled Understanding the Mechanisms of Habits and Compulsivity, a Neural Decoding Approach. And today he will be discussing the topic of leveraging cognitive neuroscience for making and breaking real-world habits based on his recent review publication in Trends in Cognitive Neuroscience. If you have any questions during his presentation, we will have a Q&A and discussion at the end of the session. So you can write them, for example, in the chat, or just write them down somewhere for yourself so that we can discuss them in the end. The session will be recorded and shared on our YouTube channel, as all previous events and sessions as well, so you can then go back to them. And now, please, Eike, over to you.
Okay, let me just try to share my screen. Okay, did that work?
Let's see. Looks good to me, at least.
Okay, well then, thanks very much for your kind introduction. So indeed, I'm going to present today about the paper that we recently published in Trends of Cognitive Science, leveraging cognitive neuroscience for making and breaking real-world habits. So habits play an important role in our lives. When we think about habits, we may consider behaviors such as the route we take to work, checking our emails when we open our laptop, making coffee every morning, or exercising. We may also think of bad habits such as biting nails or consuming unhealthy snacks. So given this range of behaviors, when we talk about habits, it's essential to begin by addressing a fundamental question, which is, what exactly do we mean by habits, or how do we define habits? The concept of habits is not universal. It holds different meanings across various research domains. And the term habit can mean different things to different people as well. So in our paper, we define habits as behaviors that occur in response to familiar contexts or cues developed through frequent repetition. So habits are context dependent, and the idea is that they kind of gradually build over time. Now, imagine this. You just relocated to a new city for a job. At first, every trip to your workplace requires deliberate thought. You're actively thinking about where to turn, paying close attention to street signs and landmarks, and maybe you even rely on GPS to make sure you don't get lost. But then as you take that route repeatedly, something changes. The landmarks become familiar, and you kind of no longer need to consciously think about each turn. And it's kind of like you just know, and you're kind of navigating on autopilot. So this example illustrates the two key characteristics of habits. They're context-driven, so your daily route becomes habitual because of repeated exposure to the same cues, which could be landmarks, intersections, and the familiar streets. And the behavior becomes cognitively efficient. So over time, the effort required to navigate reduces, and the behavior becomes very cognitively efficient. And this cognitive efficiency is critical because it frees up mental resources. So once a behavior is a habit, it no longer requires higher order cognitive processes, or less anyway. And this allows us to reallocate those resources to more complex tasks that demand attention, such as problem solving or creative thinking. So you can think about your daily commute. Once you're on autopilot, you probably have the capacity to plan ahead, think about challenges at work, or listen to a podcast, be on a phone call. And the major advantage of habits is their stability under suboptimal conditions. So habits enable individuals to perform routine actions even when feeling rushed, distracted, or stressed. So you can think about leaving the house in a rush. You're still able to do certain things like locking your door, even though you may at some point be unsure if you actually did lock your door, because it's just so automatic. So now that we've kind of defined habits, the next question is, how can we better understand them? And here I'm going to introduce the dual systems framework. So habits have long been conceptualized within this framework as resulting from a balance between two systems. So on the one hand, we have the goal-directed system, and this guides behavior deliberately based on current beliefs and goals. And this has two components, which is action outcome expectancies. So this is the understanding that a specific action will lead to a specific outcome, and outcome values. So this is the value or importance assigned to that outcome. And then on the other hand, we have the stimulus-driven system. And this system operates fairly automatically and is triggered by familiar context or cues based on past experiences. And this relies on stimulus-response associations, which are direct links between a cue and habitual behavior. And maybe important to emphasize here, so again, for us, we define habits as the behavior because ultimately that's the behavior that we want to change. So we want to get people to engage in good habits, good behaviors, or break their bad habits, stop their bad behaviors. But some other people use the term habit, for instance, to refer to this stimulus-driven system. And so then there's a balance between these two systems, and habits are expressed whenever the stimulus response associations are stronger than the goal-directed strength. So that's the idea in this framework. Now, the downside of habits is that having well-trained habits can make it difficult to adapt. And I'm just going to give an anecdote from myself. So growing up in Germany, when I approached the streets, I always looked left, right, left, because that's what I was taught and learned from early on. But moving to Ireland, I actually recognized the traffic is in the opposite side. And so in this context, I should actually look right first when I'm approaching to cross. And so this creates this conflict between kind of the habitual tendency that I've developed over many, many years, most of my life, and what I need to do in the current context. And we can integrate this into the framework as well. So in the stimulus-driven system, we have the habitual tendency, which is what I learned looking left. And in the goal-directed system here, we have the current context, which is looking right. And so when these compete in this case, habits are expressed when, again, the stimulus-driven system is stronger than the goal-directed system. And in this case, this would lead to what we call action slips. So if the stimulus-driven system is stronger in any given moment, I would look to the left first, even though that's not appropriate in this current situation. And this can explain why habits persist even when goals or intentions change. Now, habits, whether good or bad, at least so is the idea, share then the same underlying mechanism. And we could really say that good and bad habits are two sides of the same coin. So the same processes that make good habits easy to maintain also make bad habits difficult to break. And the only difference is really in their outcomes, right? So good habits lead to positive outcomes, whereas bad habits lead to negative outcomes. But if you think about my habit of looking left first when I approach the street, it's really a good habit when I'm in my normal context, but then it's a bad habit when I'm in the new context, right? So it's really just about the outcomes, but the mechanism would be very much the same. So based on this, we then refined our definition to include that habits often persist even when they are no longer aligned with our current beliefs and goals. And this is important because this is also often observed in behaviors that are impulsive or compulsive. So here we can think about eating unhealthy foods or substance use or hand washing, for instance, in OCD, which a lot of times are also against people's explicit beliefs and goals. And so therefore, these behaviors have been characterized as habits by some and explained through the relative dominance of stimulus-response associations over more current, flexible, higher-order cognitive processes. Okay, so now to the next question, which is how can we study habit mechanisms? So I'll explain this with this figure from the paper. So in panel A, this is a bit of a repetition. We see the stimulus-driven control system and the goal-directed control system. So on the left side of panel A, we can see the stimulus-driven system, for instance, a pedestrian approaching a familiar junction. And because the junction is familiar without much thought, they may automatically turn left if that's their habitual route home. And then on the right, we have an illustration of the goal-directed system, which would be, for instance, if the individual has the goal to get food. So they may want to go to the store because that's where they can get the food. And they also represent that turning right will be the right action to get to the store. So here we have the expectancies and values involved. And so then if we move down to panel B, when the two systems are in agreement, which is on the left-hand side, it is actually difficult to determine which system is driving behavior because they both point in the same direction. So here, if the habitual route is taking the left turn and let's say the individual is looking forward anyway to going home and watch TV, then it's very hard to determine what system is driving behavior. So in research, therefore, we often focus on cases where the two systems conflict. So for instance, if the individual intends to go to the store, but then the familiar context actually triggers the habitual left turn instead. And this is a really good example to illustrate habits in everyday life, because a lot of times we don't actually notice that we engage in these behaviors. It's only when we have to deal with a change that we actually realize that we make these action slips and then actually rely on these automatic responses. Okay, so I've already mentioned how good and bad habits are two sides of the same coin, and this has implications for behavior change. So in the paper, we basically say that the expression of a habit can be promoted by strengthening the stimulus-driven system or weakening the goal-directed system. And then it's just the opposite for discouraging habits. So that can be done by weakening the stimulus-driven system, or strengthening the goal-directed system. And this is just a list of all the factors that we discuss in the paper, and I will go through some of them here in this talk. Okay, so making habits. So for making habits, repetition is probably the best known mechanisms for habit development. And I have here an illustration of a typical task that is used to study habits, in this case in mice. So usually there's a training phase where the mouse first learns that pressing a lever will lead to a valued outcome, which in this case is cheese. This is then followed by an outcome devaluation phase where the mouse gets access to a lot of cheese. So it's satiated, and this should reduce the value of this outcome. And then in the test phase, we test if the mouse still engages in the behavior or not. And so the idea is that if behavior is under goal-directed control, the mouse should refrain from pressing the lever, which is indicated here on the bottom left. It's just turning away and not interested in the lever. Whereas if it's stimulus-driven, then it should still press the lever, even though it's leading to an outcome that has actually been devalued. And here in this figure, we can also see that this incorporates the level of training. So typically the idea is that behavior is goal-directed after a few repetitions, minimal or moderate training, and becomes stimulus-driven with extensive training. But it's actually important to note that the evidence for this, so habit expression as a function of repetition, is quite weak in humans. There's been one key study by Tricomi and colleagues where this was initially found, but since then a few multi-site replication attempts have actually failed to replicate this. And even rodent work, it's a little bit ambiguous. So one possible explanation is that humans are just very good at goal-directed control, and this may be especially the case when they come into the lab to participate in an experiment. So the idea is that habitual tendencies may form with repetition, but maybe they're not expressed because people engage in goal-directed control. And so this led to the hypothesis and test that habit expression is actually time dependent. And I've cited these two papers here, which came out kind of about the same time, that both very elegantly illustrate this. Basically, the idea is that if you put participants under time pressure, you kind of eliminate or at least weaken their ability to engage in goal-directed control. And as a result, that's when you see these habitual tendencies actually expressed, and you can observe habits after extensive training. And so this is something that I have replicated myself. So I'm going to present some unpublished data in which we replicate this finding. And this procedure, the task that we use here, is very similar to the one that was used by Hartwig and colleagues in the original study. So in this study, we have 30 participants. This is a within subjects design, and participants undergo 1 day minimal or 14-day extensive training. And the task looks like this. We have on each trial a stimulus that is presented, and participants have to learn to respond correctly. And in total, there's 4 stimulus response associations that participants learn. And they have a different set for the minimal training than for the extensive training, of course. So they kind of do this twice, just once, 1 day, another time, 14 days. So then after this training, there is a remapping. So as you can see here, for 2 of the stimuli, the response that is the correct one actually switches. So it requires participants to learn a new mapping until they're sufficiently have learned this sufficiently. And then in the next step, participants are tested in a forced response test. And this is a very elegant method, again, introduced by Hartwig and colleagues, where basically the time to prepare a response is manipulated. And the way we've done it here is participants hear 3 tones that are equally spaced. So like beep, 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 something like this. And participants always have to respond on the 3rd tone. And the response preparation time is manipulated by varying the onset of the stimuli. So on some trials, participants only have 400 milliseconds to respond. So the stimulus is presented quite briefly before the 3rd tone. And on other trials, they have 1,100 milliseconds to respond. So they have more time to respond. And so what we find, and this is, again, very much replicating previous work, is that habit errors increase significantly after extensive training. And this is especially the case for short response preparation times. So here, what is plotted is the proportion of habit errors on the y-axis. And then you can see the minimal training, 1-day training condition in the lighter shade of blue, the 14 extensive training condition in the darker shade of blue. And you can see for short response preparation time, 400 milliseconds, they make significantly more habit errors. Our own findings and the findings in the literature then led us to kind of visualize this interplay between the two systems in the following way. So here on the y-axis, we have the system strength, and then on the x-axis, we have response preparation time. And then the two systems in different colors, the goal-directed system in the blue color and the stimulus-driven system in the orange color. And so what you can see here is that over time, the system strength for both increases, but the stimulus-driven system strength increases much more quickly. So especially in this early time interval, we see that the stimulus-driven system already reaches its peak, whereas the goal-directed system is just slowly starting to accumulate. And then the gray bars indicate the habit expression. So that's kind of the difference between the two, right? So we are thinking about it as a balance. And the difference between the two is then the likelihood for habit expression. And we can see, and this is based on the empirical results, that habit expression is most likely when participants have very little response preparation time, and less likely when they have more response preparation time. And what this allows us to do is then vary the strength of the two systems. So in panels B and C here, you can see varying strengths of first the stimulus-driven system and then the goal-directed system. And if we look at the panel B first, here we can see what probably happens as a function of training, which is the stimulus-driven system, the orange line here, becomes stronger, and stronger in this case means it reaches its peak probably a little bit earlier, and the kind of peak itself is much higher. And as a result, we see that the habit expression with the gray bars here indicated is much larger, especially for those early time intervals. And then panel C is kind of the variation of the goal-directed system. So here we can see on the left side of that panel that when goal-directed control is weak, we also see more habit errors for short preparation times, but even for late preparation times. So the idea is that even when people have more response preparation time, when their goal-directed control is impaired for some reason, they would still make more habit errors. And then on the right side of that panel, we see that there would be effectively no habit responses at long response preparation times. But there would still be some at the early response preparation times because the goal-directed system has just not come online at that point. Okay, so this conceptualization has a few implications. So one implication is that this could tell us something about individual differences in habit formation. So this interplay can possibly help us explain why some people develop strong habits more readily than others. And it can also tell us about differences in how individuals integrate and use these systems, and the extent to which it makes them susceptible to habitual behaviors. It can also help us explore the relationship between the stimulus-driven SR strength and psychopathology. So it's possible that certain psychiatric profiles are associated with this SR strength that we're able to kind of independently identify. And then finally, this can also have implications for investigating the neural basis of these interactions between the two systems and provide insights into the neural underpinnings. Okay, so then going into exploring individual differences. So this is again from the study that I just presented that is in preparation. So this study here we're actually trying to get at the neural underpinnings. So this is an EEG study, but I'm not going to present those preliminary results here, and instead just go into the behavioral results. So as we can see, there's quite some variability in habit errors for the people that did the 14-day training. So some people make really a lot of habit errors. The majority of the responses are actually habit errors, whereas some people make effectively zero habit errors. So we're of course wondering why that is, and one way we try to get at it is with the EEG results, but there's also something interesting in the behavioral results actually. So this is from the training. So this is just the 14 days of training. There was 2 in-lab sessions, day 1 and 14, and then in between participants went home and did the training at home. And the main takeaway here is basically performance becomes more automatic, if you will, with extensive training. So we can clearly see over time participants become faster at executing their responses. So we looked at, is there any relation between the extent to which behavior has become automatic and habit errors? Sorry. So initially, it is of course plausible to look at the reaction times at the end of training. So session 14. So by the end of training, we could imagine that the people who are the fastest would make the most habit errors, right? Because maybe they are the ones that have formed the strongest habit. But this is actually not what we see. So the correlation here is, if anything, in the opposite direction, and it's not significant. And then we also looked at the baseline. So what about the reaction times at session 1? So just when they start and do it for the first time. And again, here, we don't see a significant correlation between the speed, the reaction times of participants during training and habit errors. But then, very interestingly, we actually do see a correlation, a significant correlation, when we take the difference. So this is for each individual looking at how much did they improve from session 1 to 14. And here we very nicely see that the participants that improve the most in terms of reaction time actually make the most habit errors. And this suggests that it's maybe something within individuals. So how much more automatic, if you will, has the behavior become for an individual that is associated with more habit errors. Okay, so that was a little bit about the individual differences. Then next, what about psychopathology? So research has linked deficits in goal-directed control to several disorders, most prominently, I would say, OCD, but also substance use and certain aspects of eating disorders. And recent work has shown that these observations can probably be best explained via the existence of a transdiagnostic compulsivity dimension that's kind of common in all of these. And this is evident in the general population, but also in patient samples. But much less is known about the stimulus-driven system. So does that relate to any psychiatric disorders as well? And in the paper, we put forward the hypothesis that the stimulus-driven system may be most related to repetitive clinical behaviors such as tics, flapping, and body-focused repetitive behaviors. And this is supported as well by some findings from neuroscience. If you look at the neurotransmitters that are involved, this is very much plausible. And the cool thing is that if we combine this with the visualization from earlier, this allows us to kind of map certain psychiatric profiles onto these systems. And so the idea is that these systems can be seen as somewhat independent, and we would have maybe certain eating disorders, substance use, and OCD on the bottom left here, which again has been linked to like these deficits in goal-directed control, and then some other disorders such as tics, or specific behaviors such as hair pulling, nail biting on the top right. And this could then also explain things like comorbidity that we see, right? Because it's very much possible that it comes kind of from different sources. So certain behaviors, compulsive behaviors that we see are more the result of an exaggerated stimulus-driven system, whereas others are more result from an impaired goal-directed system. Okay, then finally, the implications for understanding the neural underpinnings. So here is the very simplified illustration of the pathways in the brain. So the goal-directed neural pathway and the stimulus-driven pathway. And here again, much is known about the processes that are involved in goal-directed control. And this includes stuff like representing values, comparing values, being sensitive to changes in values. But in humans, at least, less is known about the stimulus-driven pathway. So again, understanding habits as a balance between the two and being able to tease them apart probably will have some exciting implications for understanding how this is represented in the brain. So in the paper, we raised some outstanding questions sort of as a future for the field, and two of them relate to what I just talked about. So the first one is how do SR associations develop in the brain and then dynamically interact with goal-directed mechanisms? So this is something that I'm currently working on. And yeah, we hope to have an answer to very soon. And then the other question is about the distinct psychiatric profiles associated with this overactive SR system. So that's again something that we will hopefully be able to have some answers to soon. Okay, so then it's of course not everything clear and agreed on. So there is quite some debate in the field, and I think that's important to acknowledge and discuss. So an important debate, I believe, is about the role of beliefs and goals in habits. So in the paper, we mostly apply the dual systems framework. And in the dual system frameworks, ultimately behavior results from SR associations. And these SR associations are independent of beliefs and goals. So in the moment the behavior occurs, it's just a stimulus that automatically triggers a response that then leads to the behavior. But yeah, this has been challenged by different researchers or acknowledged by different researchers. And so one of the arguments is that we're kind of mapping automaticity onto the stimulus-driven system. And this makes it seem like the goal-directed system could not be automatic. But there's also research showing that the goal-directed system or goal-directed processes can very much be automatic as well. So we can think about automatic retrieval of goals via reinforced stimulus-goal associations. So every time you engage in a behavior, it may not only strengthen a stimulus-response association, but also a stimulus-goal association, right, with the goal that is involved in the behavior. And then computations can also very much become automatic. And so in the paper, we kind of summarize this as habits of thought. That's how we label it. And just to illustrate this, so imagine you're encountering a red light in your car. Pressing the brake pedal could be resulting from a stimulus response association where it's red light, pressing the brake pedal, but it could also be mediated by an automatically activated goal to stop the car. So it wouldn't be red light, press the brake pedal, but red light, stop the car. And then this could very well involve two components, which is once the stimulus triggered goal, which is the red light signals stopping the car, and also action outcome expectancies. So that is the belief that when you press the brake pedal, you're actually stopping the car. And so this is something that I've worked on during my PhD. So I'll just briefly present some results here. So in this task, we had participants do 1 day or 4-day training. And they initially had choice trials where they're presented with 2 doors of the same color, and they would have to press the left or right key to knock on the door. So in this task, participants learned 4 associations. So for 2 of the doors, there was a diamond behind the left door, and for the other 2 doors, the diamond would be behind the right door. And then that was the valued outcome. The non-valued outcome was a rock. And then you can see here what a trial looks like. So participants press left or right. There's a hand knocking on the door, and then participants see the outcome. And they were instructed and incentivized to earn as many diamonds as possible. Now, then after the 1 or 4-day training of this, there was a reversal where for 2 of the doors, the diamond was now behind the other door. And then we had a new trial type, which was expectancy trials. So in addition to the choice trials, we then had expectancy trials. And expectancy trials looked something like this. So in these trials, participants are presented with the 2 doors, but instead of choosing the left or right door, the hand was just knocking on one of the doors for the participants, and the door opened. And then participants were asked, do you expect a diamond or a rock behind the door? And this was with a response deadline of 500 milliseconds. And there was 2 different keys associated with this. And then the cool thing that we found is that there was a good amount of habit errors that participants made. So in this case, it's choice errors. So that's the choice trials. But there was also a good proportion of expectancy errors. And yeah, the really cool thing is that we found a nice correlation between the 2. So contingency errors were associated with more habit errors. And what this may suggest is that habits, in this case, may also occur because people retrieve automatic beliefs. And in this case, they may retrieve incorrect old automatic beliefs. So they still think the diamond is behind the door, even though it no longer is. So it may not just be actions that become habitual, but also, beliefs and goals. And what this really suggests is that habits are likely more complex than just SR. And I think it's something that's important to acknowledge because it also provides new avenues for research to find better ways to understand the behaviors that we're interested in and to develop a better intervention as well. And I think this is something that's applied as well, for instance, to substance use, and there's some interesting findings coming out in this area. So I think it's important to kind of have this block to acknowledge the debate that's going on and also kind of show that there's a potential in this area. And so because of that, one of the outstanding questions that we had in the paper is basically about the role of habits of thought. So automatic beliefs and goals, what role do they have in habit expression, and what implications does this possibly have for understanding and treating compulsive disorders? Okay, now I'm going to move on to the breaking habits section. So in this section, we discuss several strategies that can break the cycle of maladaptive habits and foster behavioral change. And the first one that we discussed is weakening stimulus response links. So again, here you can see the visualization. So earlier, I kind of explained how repetition would basically lead to a strengthening of the stimulus-driven system, which is the orange line. And so basically the best way to break habits would be to kind of reverse this, right? To weaken the stimulus-driven system. But this is incredibly difficult because stimulus response associations are enduring. Some would maybe say they're kind of impossible to break. They're always kind of lingering. We do know from extinction studies that refraining from a response does not erase these associations. So indeed, that does suggest that that associations are prone to stick around. And another thing that we know is that old memories are especially likely to be retained after abrupt changes. And I think that's something that's, of course, very important for practical behavior change. So we think about New Year's resolutions, right? That's a lot of times something that's quite an abrupt change. So on the 31st, someone may still have the last day of engaging in some bad behaviors that they're aware of, and then the idea is that like the next day they just completely turning it around. But with these abrupt changes, old memories are especially likely to be retained. That's very important to be aware of. There is some promising results from clinical trials, pharmacological research, and also translational experiments here. So for instance, there's some evidence that behavioral interventions may actually reduce activity in the putamen, which is the posterior putamen, which is the area that it has been identified as important for the stimulus-driven system. And so this may suggest that certain behavioral interventions reduce the expression of behavior through kind of weakening the stimulus response associations in the brain. In rodents, it has been found that the corresponding brain area is involved in the formation and consolidation of SR links, but also possibly in their extinction. So this presents a promising target. And this is something that has been shown maybe more convincingly in rodents. Certain agonists have been shown to enhance extinction, and this has been then further shown to facilitate the extinction, for instance, of cocaine-seeking behavior in rodents. It has also been used in humans to supplement behavioral interventions, and has some promise, but more work is needed in this area. So then the final outstanding question basically that we raised in the paper is based on this. Are there ways to directly alter or break SR associations? And this would probably be the most effective way to change habits, to break habits, because a lot of the strategies that we do have do not directly target those associations, but rather go around it. And I'll get into that in a moment. One of those is goal-directed inhibition. So if we have kind of prepotent habitual tendencies that we want to that lead us to make bad habits, one strategy is inhibiting those tendencies. And basically the idea here is to strengthen the goal-directed system as it is shown here on the right side of this panel, which leads to two things. It leads to earlier intervention of the automatic tendencies, but also, just a much stronger intervention in inhibiting these tendencies. So this can be done in two ways. So it can be done by avoiding conditions that weaken goal-directed control. And there's a number of conditions that have been studied. So stress is probably the most studied one, but we also have working memory load. We have sleep deprivation, for instance, as well. And yeah, basically, there is evidence that these conditions can impair goal-directed control. So refraining from these conditions kind of in everyday life is definitely a strategy to make sure that there's not the switch to stimulus-driven control. But it's also important to say that more work is needed in this area to really consolidate some of these results. So there has been some replication attempts, including one of my own, for instance, of the findings that stress causes the shift, that have been unsuccessful in basically replicating some of the earlier findings. So this is something where more work is needed, but definitely one strategy that is applicable to everyday life as well when we think about breaking habits. And then the other way when we think about inhibition to break habits is strengthening the goal-directed system. So here we know that goal-directed processes rely very much on motivation, and there's some evidence that motivation-based feedback in combination with monetary incentives can be effective in the lab to reduce habits. So that's very interesting, of course. And then there's a line of research on brain stimulation, non-invasive brain stimulation, which has shown that stimulating the areas in the brain that are associated with goal-directed control enhances inhibition of habitual tendencies. And this is also very much clinically recognized. So brain stimulation partially is used clinically, but also, of course, inhibition constitutes a core component of, for instance, exposure therapy. And the monetary incentives are a mechanism in contingency management where individuals are kind of rewarded for sticking to their schedule of being abstinent. And then, the final factor that we've identified for breaking habits is competing stimulus-response associations. So here in panel C, you can see that even on the right side, where the goal-directed control is quite strong, the goal-directed system is quite strong, there may still be habits at very early response preparation time. So there may be windows where habits are expressed just because the goal-directed system cannot operate at those times. And so the best way then to kind of break a habit is probably to have an alternative behavior that competes with the existing habit. So we could think about something like implementation intention, so if-then plans. So it could be something like, if I feel stressed, then I will go for a walk, maybe instead of engaging in the bad habit, which may be something like eating unhealthy food or something like that. Having an alternative and making sure that this alternative can compete with the existing habit, because goal-directed control may not be enough. And then another really nice method, I think, is script elicitation, which is just kind of this idea that individuals can kind of develop a script of their routine and really write this up in all the details. But then a part of this is also coming up with an alternative routine, alternative behaviors. And again, those then can compete with the existing habitual tendencies to ultimately break habits. So this is just the outstanding questions again that we listed in the paper. So we had 4 outstanding questions. The first is about the interactions between the 2 systems in the brain. The second one is about distinct psychiatric profiles and how they link to, in particular, the SR system. So is that related to repetitive behaviors such as tics and flapping as well? Then are there ways to directly alter or break SR associations? So as I said, most effective strategies do not directly target the existing associations, but this would be very powerful. And then finally, the habits of thought, right? So really extending the framework and considering alternative explanation of automatic beliefs and goals. What are the roles of these and habits, and what implication does this have for treating disorders of compulsion? Okay, so this brings me to my last slide. Thank you for your attention.
Wow, thank you so much, Ike, for this amazing and very clearly explained presentation. Such interesting research you have been doing, and very big questions you have raised in this review that you just shared with us. Yeah, so without further ado, we have some time for questions and discussion here at the end. So, anything come to mind? We have Isaac. Yeah, just feel free to open the mic and ask your question.
Okay. You hear me?
It's a bit, wait, here. Can you talk again?
Did you hear me okay now?
Yes, perfect.
Okay, sounds good. Thank you, Ike. That's very interesting research. My name is Isaac, and I'm currently in the Department of Psychology here at Essex. I just have a very quick question about when you are saying that we can develop a competing habit to help us break the existing habits. And then you use an example saying that we can try to develop this cue response association. For example, like when I feel stressed and then I go for work. And I just have a question because my understanding is that when we're trying to develop new habits, then we probably need to engage in some kind of goal-directed control. We need to put in conscious efforts. And I'm just wondering, but earlier you also said when we feel stressed, then it's difficult to engage in goal-directed control. So I'm just not sure in contexts like this, how effective is it to use stress as a cue to develop a new habit to help us to break the current unhealthy existing habits? So I guess just I would like to hear more clarification on that. Thank you.
Yeah, I think that's a very good question. So I would say the best way maybe to apply implementation intentions is before you're actually in the situation, right? So it's this strategic planning ahead. And like you said, it's very much dependent on goal-directed control. So the best way to apply it is to do it in a moment when you're not stressed and then connect it with that cue. Now, maybe stress is not the best cue in that case, but I think, yeah, like it's really this strategic goal-directed control that are implementation intentions to plan ahead for a situation so that when you are in the situation, the link is kind of already established before, right? So even with stress, it may be possible that because the link has been already established, that you can rely on that link in a way in the moment when you are stressed.
Okay, that makes sense. Thank you.
Perfect. If I may, okay. Actually, Ben had another question. I was going to continue. What's your question on, Ben? I was going to continue about the same topic of competing associations.
Okay, please do. I've got a different question.
Okay, excellent. I'll be brief. So, yeah, you mentioned that in relation to these competing associations or developing them, for example, through implementation intentions, that the new behavior must be able to compete with the existing one. So is there some, like, are there some characteristics or features of behaviors that are most likely to develop into, alternative competing associations? If that makes sense.
Yeah, I think it does. So maybe this relates to something that I didn't cover in the presentation. How long does it take to form a habit, right? That's something a lot of us are interested in. So I would say if you're looking for a competing habit, it ideally should be something that you can form like relatively quickly in that sense, just so that it kind of reaches this a level of automaticity. But at the same time, of course, it has to be something that fulfills the same role of the behavior that you're trying to get rid of. So if it's too simple of a behavior or doesn't fulfill the same role, it's maybe not going to work.
Perfect. Yeah, that goes to a question I had once from a client who asked that, how could I switch my chocolate eating to eating a lemon? So yeah, one may think if it might not exactly target the same. Yeah. Okay, Ben.
Yeah, I have a kind of translational question, quite a blunt one. Based on your understanding or your kind of definition and treatment of habit, what would you understand if someone said to you they have, say, a physical activity habit? I'm just trying to think how your approach kind of plays out in everyday complex behaviors.
Yeah, I think that's a very good question. It's always about what do we capture with our definitions, and I think we have skills, we have routines, we have habits, right? So it's always very important to define what we're talking about. And I don't know if I have an answer immediately to your question. I would say we probably would need to see to what extent the habit that somebody refers to as a habit is actually related to the mechanisms, the way we understand it in the lab. So I don't, maybe there's been some work on this, but yeah, I think that's probably the way to do it. So I think with the definition that we use of habits, it possibly includes some behaviors that we first basically need to study to determine, okay, should they actually be included in this definition? And of course, the exercise habit is something that's very complex because you can break it down into like many different components, right? There's like actually, yeah, let's say grabbing your gym bag and going to the gym, but then you also have the actual exercise itself. So it's always a bit of a question then, what exactly is the habit in this, if that makes sense. But yeah, it's complex to very clearly say if something can be considered a habit under this definition.
Okay, great. So then we have one question in the chat from Ignacio Biso. So based on your preliminary data on individual differences, looking into RTs to explain habit errors, did you check error rate during 1 versus 14 sessions to relate to habit errors at reversal? Perhaps are also linked inaccuracies, which is the same measure type.
Yeah, that's a very good question. And I did look at that as well, but the problem is that the error rate is so low that there's just not enough variability to relate this. But in principle, yeah, you would expect the same correlation based kind of on the whole idea. So yeah, less errors would probably less errors during training would probably be correlated with stronger habits in that sense, and then more habit errors. But yeah, there's just not enough variability, unfortunately.
Okay, we are just about on time. We have a couple more questions if you're not in a hurry. I suggest
sure.
we take them if that's okay. And for others, thank you for attending. Please remember how to get connected. I added them to the chat for those of you who need to leave. Yes. David, I think you were first.
Hi, thank you, Anka, for this talk. Very interesting. So, my question is about this concept of habits of thought, these automatic goals. For me, I sometimes struggle with it because, okay, these goals are automatically triggered by a context or by a stimuli, and also these goals become automatic with repetition, with practice, if I understand this okay. And also they are sensitive to preparation times because, so how do you distinguish these goal-based responses or goal-dependent responses from the stimulus response real habits? Because they are very, very similar. They develop in the same way, and you expect both of them under the same conditions. So, so that's what I think. Maybe it is not possible to distinguish between these two theoretical concepts. They are maybe too much theoretical and very difficult to to get a handle of.
Yeah, I think it's a very good question, and it's obviously something that I have thought about a lot, even during my PhD and the work where I was more critical of the dual systems framework. And I think we can, yeah, try to be innovative and find new ways to assess this question. And I think it's important to note that this is not a question that's interesting to everyone, right? So if you're just interested, let's say, in the practical implications, then knowing that repetition leads to more habit expression, that's valuable. And if you know that something like time pressure or stress makes habit expression more likely, that's valuable as well. I think the question then ultimately about what are the mechanisms or the representations, is it just stimulus response, or is it beliefs and goals that are automatically processed, is something that I'm still interested in and working on, and just I guess trying to find new innovative ways. But indeed it is very complicated, and they do have the same characteristics, indeed. So for some, maybe it's also a question of preference then, I guess, in terms of which way they prefer to interpret it. But yeah, it's ongoing work that we still pursue to try to get to the bottom of this. So one way we've done it is with this paradigm where we ask people about their expectations. And yeah, there's more work ongoing with this paradigm. We're trying to improve it. But yeah, I think in the literature, some also, maybe yourself as well, say, well, it's maybe not the question that we should ask, right? If we know the factors under which habit expression occurs, then that's maybe more interesting. So just different angles, I would say, to habit. So it's, I would say it's not interesting for everyone, but it's a difficult problem. Yeah.
Thank you.
Yeah, Paula.
Yes, so I had my question was very similar to David, actually. Yeah, I was wondering if what would be your hypothesis for the neural mechanism of these habits of thought that you mentioned, because I completely resonate with you, and I think this is a very relevant topic, especially for OCD, which I also research about, and I see clinically that we cannot say that it's a stimulus driven, because they believe that even though they have done it for many years, they still believe that they should do that. That's a goal. So this is very interesting, and I think it's a nice concept to include in the research. But I just wonder, what are your hypotheses in terms of the neural mechanisms? How do you distinguish them from the habits as we used to consider? So
yeah, again, a very good question. I think especially with some of the newer paradigms we have, we are much better able to study habits, I think, and that's already a good step. And I think then the next step is probably to really get more solid neural or brain mechanisms, because even for the stimulus, or what we call the stimulus-driven system, we don't know. And I think maybe then ultimately we can try to see, because it's also possible, right? Like what we call now stimulus-driven system, it's not impossible that it is actually also including habits of thoughts, right? We don't know. So I think we probably need to get first good neural signatures of the tasks that we use and that we know that are valid and reliable. And then I think in the next step, kind of trying to distinguish between that. But it's hard to speculate about the brain mechanisms, I think, involved at this point. So I think we need more work first, probably. But yeah, it's very interesting. And I'd be interested to also talk more about that, to hear your experience as well.
That would go like to putamen would be included, like, because from previous research in rodents, we think that putamen premotor cortex are linked to habits. But do you think this would be the same? Is there a hypothesis that could be that those reasons as well, or would be more like?
I think they certainly would be included as well, because even I think for the habits of thought, they probably have to contain this like motor component of the habit. But then in terms of the thought component, beliefs, yeah, I'm less sure, I think.
Yeah, thank you so much. I was just curious about what you think about
yeah,
it.
it's a very good question, I think.
Thanks.
Excellent. It sounds like there would be an opportunity to arrange a just purely discussion around this topic. Now that we have, people who are interested in the, in the topic. Did we have any other questions, or shall we wrap it up for now? And seems that unless Paula had another one, or did you just leave your hand up by accident? Well, again, a warm thank you everyone for participating, and thank you for the excellent questions, and a special thank you, of course, to our guest speaker, Eike. And you will find the session on on YouTube, hopefully shortly. Good.
Thanks again.
Thank you. Have a great December, everyone, and end of year.